Hi. Hi. So I'm going to be talking about different tools to move data in and out of DAOS. So the idea is that there would be tools available to move data from a POSIX file system like Lustre or GPFS to DAOS and back. There are many reasons why you'd want to do this. One could be that the DAOS system is small and can't accommodate every user's data. So you might have to move the data in for a job and then back out when the job is done. So we want to have tools to facilitate this kind of data movement from DAOS, in and out of DAOS. So another way to store DAOS container data on POSIX file system is with serialization, which can be done with any container type. So DAOS serialization just means that the container data is and metadata is written to an HDFI file in a standardized format, and then this file is what's stored on the POSIX file system. And so when you are ready to use the data again, you would pass this file to a deserialization tool, which would re-import your data back into DAOS so that you can use it. So for both of the previous cases for copying and serializing data, there's parallel tools and there's a serial tool. For parallel tools, we use mpiFileUtils, which is a parallel set of file utilities that use MPI. There's a DAOS backend written for it. It is separate from the DAOS code base and requires having MPI and then installing mpiFileUtils separately from DAOS. And if you want to use serialization and deserialization tools, you also need HDF5 because it writes these files in an HDF5 format. So these are some of the tools in mpiFileUtils that have a DAOS backend that allow you to copy and remove and compare data or sync data, which only copies the difference between the source and the destination. For the serialization tools, these are were written specifically for DAOS, so they're not like the other tools in that you can use these other tools without DAOS, but these tools are for DAOS specifically. And this is just a couple of examples of how you would run a copy job using mpiFileUtils and DCP specifically, which is a copy. You need to launch MPI and then specify the number of processes that you'd like to run. And in this case, it's running from Lustre as the source into a DAOS container. And that's just specified with a DAOS prefix and the colon and 2 forward slashes. And then you can specify a pool slash and then a slash and then a container label. You can also use a unified namespace path as a destination if you have one. And then for serialization, it's similar. You launch with MPI, the number of processes, and the tool. And this option allows you to specify an output directory for the HDF5 files. You don't have to do that. It will just write into the current working directory if you don't specify a directory, but it is more convenient because in this case, it's going to write multiple HDF5 files because the container is going to be split across the 3 different processes. So it's going to have 3 separate files. So it's more convenient to specify the directory there. And then you specify the pool and container you'd like to serialize. And then once you're ready to import the data back into DAOS, you use the deserialize tool where you need to specify a pool that the container will be serialized to. And then the directory where the files are contained, the HDF5 files. There's some more examples in the documentation at this link too. There's also a serial tool that allows you to move data from POSIX to DAOS and back. This is specifically for POSIX data. It's provided with the DAOS RPM, so you don't need to do any separate installations or have MPI or anything like that. There's not currently any support for serialization tools, but you can copy POSIX data in and out of DAOS with this tool. And then you can run this tool after you have DAOS installed. You run a DAOS file system copy and then specify your source. In this case, it's Lester, and then the destination pool and container. And then there's some more examples and documentation of other ways and options to run it in the data mover documentation, which is part of the DAOS user guide. And then this is just some performance data on GPFS. So this is copying a 100 gigabyte file from GPFS into DAOS. And this is all using one node. So the first 3 bars are all single process runs. And then the middle bar is just using a regular CP command where the DAOS is mounted, or the path is mounted with defuse for DAOS in the middle. And as you can see, you get quite a bit of a slowdown using defuse versus using a regular, even using another single process tool where you can specify the pool and container directly, which is going to be faster than using the defuse path. And then going from 1 to 4 processes, you get is about 3 times faster, but going to 8 for this size file really doesn't help much. And then this is some more performance data. It's using a 1 terabyte file this time, measuring the data in gigabytes per second. The max bandwidth for this configuration in one DAOS server was about 28 gigabytes per second. And then some of these are multi-node runs. So on one node with 8 processes, you can get about 11 gigabytes per second over the network. So it took about 8 processes, and using one process in the previous slide, it was getting about 2.5 to 3 gigabytes per second. So to get maximum performance moving a large file, it's best to use multiple processes, even on one node. And as the nodes go up, the bandwidth increases. It gets to about 21 or 22 gigabytes per second, which is closer to the 28, but not quite there with 4 nodes. And then I've just provided here some links and documentation to the mpiFileUtils repository and data mover, and just more examples and documentation on how to run. Are there any questions?
Yeah, so when you were talking about serialization, so why is it we are using HDF5 for serialization format?
So there was really no, so it was really between that or using the VOS format. And I think the reason we eventually went with HDF5 was that HDF5 was a standardized format that was less likely to change at the time. So that's what we used, and it's also used pretty widely within HPC.